Hello everybody. Today we're going to be looking at this problem. We're given real numbers a, b, and c such that c times a plus b plus c is less than 0. What can we say about b squared minus 4ac? Basically, what kind of, or what's the sign of it, basically. So we want to know, is this positive, is this 0, is it negative, or is there not enough information to say? But I'll tell you right away, we can rule out that one, that there is enough information to say what the sign of b squared minus 4ac is. How could this be? We have this crazy inequality where we're multiplying one variable times the sum of 3, and then we're trying to get something squared, and it's just, you know, I mean, in a sense, we know that this inequality is homogeneous, so, we could say a plus b plus c was 1, and c was less than 0, but still it doesn't help all too much. But let's think about where we've seen this expression before. And the first thing that should come to mind is the quadratic formula, where x is equal to negative b plus or minus the square root of b squared minus 4ac. So here we see our expression, all divided by 2a. And this is the solution set for a general quadratic equation, ax squared plus bx plus c. So we can think or basically, what does the sign of this term mean? Well, since it's under a square root, we know that for this quadratic to have real roots, this must be non-negative. Uh, and specifically, if the quadratic is tangent to the x-axis, then we know that b squared minus 4ac is 0. Because then our plus or minus, we're just plus or minusing 0, so we have the same solution twice. That's what it means to be tangent, is that we just have a repeated root. So if b squared minus 4ac was greater than 0, then you would have two roots, two real roots. And if b squared minus 4ac is less than 0, you can't take the square root, or it's not closed within the real numbers. So you'll never touch the x-axis. So we have sort of a sense of where we want to go with this problem, but we still don't know how to translate this information into this information. Except we know that the sign of b squared minus 4ac, tells us about where the roots of this quadratic are. And if we do a little more pondering, we can see that c is just, if I let this equal to f of x, so our quadratic is just f of x, then c is just f of 0, and a plus b plus c is f of 1. So we know that f of 0 times f of 1 is less than 0. And for the product of two numbers to be less than 0, and specifically real numbers, we're dealing with real numbers, then we know that one of them has to be greater than 0 and one of them has to be less than 0. So if we were to plot this, we have this quadratic, and we know that, so let's consider the case where f of 0 is negative, then f of 1, say somewhere over here, has to be positive. And just by sketching that, we see that, we have to hit the axes here. We have to hit the x-axis because f of 0 is negative and f of 1 is positive, and so the mean value, or the intermediate value theorem, implies the existence of a root between 0 and 1. And obviously, since this inequality is strict, neither of these numbers are 0, so we know that b squared minus 4ac is not equal to 0. So b squared is not equal to 4ac. So that's one case. This case, we know that b squared minus 4ac is greater than 0, so greater than 0 here. And if we just plot the other case where f of 0 is positive, it's again the same because f of 1 will be negative, and by the intermediate value theorem, there has to be a root between 0 and 1, which would imply that b squared minus 4ac, again, is positive. So, in fact, this problem, which seemed a little abstract, which seemed like a really tough, just inequality problem, ended up being a more general statement about polynomials, and specifically quadratic equations and the intermediate value theorem. So thank you for watching this video, and I hope to see you in my other ones.